Hello and welcome to Toddcast number 11. This is on functional groups, and really this is just more than anything nomenclature. So it's not necessarily going to be the most complex of lectures, but definitely this is one that you should take the information and just flashcard it, just commit it to memory. When we talk about organic chemistry, oftentimes we talk about general terms. We'll say an amine reacts with an alkyl halide. You need to know what those terms mean, and then within that reaction, we'll get more specific: what type of amine, what type of alkyl halide, what happens with different solvents. So it's a language of chemistry because it's early on right now. Um, pretty important that you, I don't know, cover those things. That said, here's the main reason we want to do this. So functional groups, first and foremost, there are specific attachment of atoms that show characteristic chemical reactivity, meaning a carboxylic acid has a carbon double bonded to an O, also has an OH group coming off that carbon, and then the last bond is to either hydrogen or another carbon in an alkyl group. So that functional group, that carboxylic acid, can undergo very specific reactions. And so by knowing a functional group, we know a class of reactions as well. So for instance, if we have a compound like an alcohol, so this is butanol, and more specifically, it is 1-butanol. If I treat it with what's known as SOCl2, that's this compound right here. So it's kind of redundant to write the name below or the formula below and the structure above. So I'll just write the structure. But if we do this, then this alcohol gets turned into a Cl. And if you follow the math of it all, 1O here is now going to be bonded to that S. So S has 1O, now it has 2. This H is going to bind with one of the Cl's, and the Cl is going to replace the OH group on that. So this is actually, I guess, the first chemical reaction we're going to have in the Toddcast series. And this is the whole reason why we go into specifically the reactivity. So the reaction was 1-butanol reacts with SOCl2 to form 1-chlorobutane. But the reality is, if we wanted to, we could make this a longer chain, and this would be pent, for instance. So knowing that the OH on a carbon chain reacts with SOCl2 to form alkyl chain with a chlorine, that's the important thing here. So again, the class of compound is the more important feature. So this is an alcohol, and specifically, it's a primary alcohol. We'll get into more detail as we go into more and more reactions, but primary, again, functional group is on a carbon that only has one other carbon attached. The primary alcohol is going to go to a primary alkyl halide. Okay, so if we choose to do the same compound, SOCl2, but react with a different alcohol, notice we still get the exact same situation. So it's still an alcohol. It's still going to a primary alkyl chloride. And now we have a secondary alcohol. And sure enough, that OH gets replaced by Cl. So in other words, an alcohol, first or second degree, or primary alcohol, secondary alcohol, when treated with SOCl2, will go on to form the equivalent alkyl chloride. Same reaction, same class of compounds. So in other words, we want to look at alcohols as a reactive group, carboxylic acids as a reactive group, alkyl halides as a reactive group, and so forth. So hopefully this seems reasonable. This is our whole purpose for doing it. So generically, we will write ROH, which represents an alkyl group, the R bonded to an OH. That same R group will now be bonded to a Cl in this reaction. So the category of compounds known as alcohols can undergo conversion into an alkyl chloride using SOCl2. It's going to be a whole series of reactions that you're going to learn this way, not specific individual ones, but generically speaking. What happens to an alcohol, what happens to uh, a ketone, whatever functional group we're going to deal with. Okay, so time to actually learn all those functional groups. So a bunch of names here, 20 altogether, and want you to just learn, 16, excuse me, want you to learn the different groups. So this is going to be a screen we're going to play kind of like a game show. Name that group, and hopefully when we get to the end, freeze the picture, take a screenshot, and literally spend time memorizing the functional groups. It'll pay dividends in very short order. So let's see, this one right here, we just did the OH on an alkyl group. That was an alcohol. So let's see. There we go. So alcohol right there. So let's bring the alcohol name up and over. Okay. We formed an alkyl chloride, so I'm going to get to that eventually, but I'm going to go sequentially down the list and see if we can figure out what the names are. So an NH2 with an R, NH2 with an R, so they seem very similar. The difference is this NH2 is next to a carbonyl, C double bond O, and an R group. This is a secondary amine and has two carbons attached. This is primary, but this is an amine because there is no carbonyl. When there is a carbonyl, it's known as an amide. So amide and amine both have nitrogen in them. So we'll note that. So the name has an N. Amine has an N. Amide is just nothing more than amine, but with a carbonyl, C double bond O, next to it. Okay, so those are nitrogen compounds. Want to know what the sulfur compounds are. So we have a sulfur here and a sulfur here. So it ends up sulfide is probably going to be pretty indicative it's one of those two compounds. So the sulfur compound is either this one, or the sulfide compound is either this sulfur compound or this sulfur compound. It ends up thiol is the other one. So OL, alcohol, thiol, not an alcohol. It has been replaced by S. So this is just like an alcohol, but with a sulfur. That's thiol, which means that's my sulfide. Okay, the word chlorine should appear. So we have a couple that we have here, alkyl halide and acyl halide. So if it was chlorine or bromine or iodine, even fluorine, if you have those in this place, and fluorine is highly unlikely here, just as a point of interest, but you can have bromine or iodide. So instead of saying an alkyl chloride, that's very specific, or an acyl chloride, we're going to say acyl halide. So this one, when you have a carbon, one carbon, CH3, connected to a double carbon with a double bond O, that group is known as an ACE. So this is ACE chloride, so acyl chloride. So that's taken care of up there. This compound has absolutely no functional groups, which means it's got to be either an alkane, alkene, or alkyne. Because it has a double bond, we call it an alkene. The sulfide, the oxygen equivalent, is known as an ether. So when you have carbons, alkyl chain, and carbons and alkyl chain, both connected to an oxygen in the middle, it's known as an ether. This one hopefully is the remaining one, that nice and easy, the alkyl halide. Ketones, notice the ketone is going to be different than this compound. So they're both double bond to O. They both have a carbon chain. But the difference is this has carbon chains on both sides. This can have a carbon chain and an H. So this is known as a ketone. The other one is known as an aldehyde. Double bond here. So this looks like an alkene. So technically speaking, it is an alkene, but when the alkenes are double bond, single bond, double bond, single bond, double bond, single bond in a ring, we call that an aromatic ring. And that's going to be a whole separate entity we'll cover in a future podcast. So double bonds, the triple bond then is an alkyne. This next one, for whatever reason, bothers people. So I'm going to give a mnemonic. It's popped up in a previous podcast if you happen to see it. And that's, ooh, it's ester. I get so excited when I see ester. I just go, ooh, couple O's. This is an aldehyde. Carboxylic acid mentioned that has a carbonyl and an OH. Last one is known as a acid anhydride. So I'm going to call it just an anhydride for now. But you should know these functional groups. These are, I guess, core to what we're going to do over the duration of studying organic chemistry. So again, good screenshot to take and memorize these, not these specific examples, but generically speaking, when you have an OH on an alkyl chain, alcohol. When you have a double bond O on an alkyl chain, a ketone. So know what the groups are. I hope this isn't too overwhelming. And this was a short and sweet podcast. Next one, 12, is we're going to get into a core concept within OChem. But hopefully this went well. And I will see you at the next podcast.